RAM. You've heard of it. You know your computer needs it. But do you actually know what it does, or why there are so many different types? In this video, we'll break down every major kind of RAM, explain the differences, and help you understand how RAM has evolved to power everything from smartphones to gaming PCs and servers. Welcome to TechGPT, where we make tech simple. RAM stands for Random Access Memory, and it plays a critical role in how fast your device feels. Think of RAM like a workbench. When your computer's working on something, like opening a browser, editing a document, or running a game, it brings all that data to the workbench for quick, easy access. The bigger and faster the workbench, the more efficiently your computer can do its job. Now, here's the key. RAM is volatile memory. That means it only stores data while your system is on. The moment you power off, everything in RAM disappears. That's different from storage like your SSD or hard drive, which keeps data even when the power's off. RAM isn't about storing your files. It's about helping your system think faster. RAM actually comes in two fundamental types, SRAM and DRAM. SRAM, or static RAM, is ultra-fast and doesn't need to be constantly refreshed. That makes it perfect for super quick operations, so you'll find SRAM inside your CPU, acting as cache memory. But SRAM is expensive and takes up more space, which makes it impractical for large amounts of system memory. That's where DRAM, or dynamic RAM, comes in. DRAM is slower than SRAM, but much more affordable and dense. It's what makes up your desktop or laptop RAM sticks. DRAM needs to be refreshed thousands of times per second to keep data stored, which is why it's called dynamic. That constant refreshing makes it a bit slower, but still way faster than your storage drive. In the late 90s, we saw a leap in memory tech with SDRAM, that's synchronous dynamic RAM. SDRAM could sync with the CPU's clock speed, which made data transfer far more efficient. Then came the game changer, DDR RAM, double data rate. Unlike regular SDRAM, DDR could transfer data twice per clock cycle, doubling its bandwidth. Let's walk through the evolution of DDR RAM. DDR1 arrived in 2000. It doubled the transfer rate over SDRAM and set the foundation for modern RAM. DDR2 improved on that with higher speeds and lower power usage. DDR3, launched in 2007, became the go-to for many systems for over a decade. DDR4 hit the scene around 2014. It boosted speeds up to 3,200 MHz or more, reduced power even further, and introduced better internal efficiency. And now we have DDR5. Launched in the early 2020s, it doubles the bandwidth again, reduces power use, and supports features like on-die ECC and 2 independent 32-bit channels per module for better parallelism. Each DDR generation isn't just about raw speed. It's also about power efficiency, capacity, and performance optimization for newer CPUs. Outside of DDR RAM, there are other specialized memory types you've probably seen or heard of. LPDDR stands for Low Power DDR. It's used in smartphones, tablets, and ultrabooks where saving battery is critical. The latest version is LPDDR5X, used in flagship phones. GDDR is graphics DDR, used in graphics cards. It's optimized for massive bandwidth, perfect for rendering high-res textures or training AI models. GDDR6 and GDDR6X are the latest. HBM, or high bandwidth memory, is even faster and used in professional-grade GPUs and AI accelerators. It's vertically stacked and sits close to the GPU die. ECC RAM stands for Error-Correcting Code RAM. It's used in servers and mission-critical systems. ECC can detect and fix memory errors on the fly, super important for uptime and data integrity. Each of these is tailored for a specific environment: mobile, graphics, servers, or high-performance computing. Okay, so let's bring it back to you. If you're building or upgrading a system, here's what to look at when choosing RAM. Type: Your motherboard supports either DDR4 or DDR5, not both. Check your CPU and board specs before buying. Speed. RAM speed is measured in megahertz, like 3,200 megahertz or 6,000 megahertz. Faster speeds help with gaming, editing, and streaming, but it depends on your CPU's memory controller too. Latency. Lower CAS latency, CL, is better, but high speeds can compensate for slightly higher latency. It's all about balance. Capacity. For everyday use, 8 GB is fine. For gaming and multitasking, 16 GB is the sweet spot. Creators and power users, 32 GB or more. Channels. Always aim for dual-channel setups. 2 sticks of 8 GB will outperform one 16 GB stick in most tasks. Form factor. Desktop PCs use DIMM. Laptops use SODIMM. Easy to overlook, but important. RAM might not be the flashiest part of your system, but it's absolutely one of the most important. Whether it's DDR5 in your gaming rig, LPDDR in your phone, or ECC RAM in a server, memory keeps your system running fast, smooth, and stable. Now that you've got the full picture, drop a comment and let us know what kind of RAM you're running. And if you learned something new today, give that like button a good tap and subscribe for more tech deep dives, right here on TechGPT.
That's odd. Let's try this. Fat lot of good that PhD does me now, This should help. Let's go. Do you smell something burning?
What is this thing?
No!
Warning. Biohazard detected.